This video is going to be talking about section 4.1, measures of location. Oh, click the wrong thing. There we go. So far we've talked about classifying data. Where does the data fall? Is it quantitative, qualitative, its levels of measurement, and how you classify the data, how that translates into a display of some sort, whether we are talking about the frequency tables or the graphs that go along with the types of data we're working with. Now we want to really focus in on the spread of the data and how to take in some basic statistics, some basic measurements, whether it be central tendencies or whether we are trying to gauge other or answer other questions about the data. So the arithmetic mean, it's the same concept of when you are given 3 tests, let's say, and your teacher tells you that she's going to use an average test grade. So for example, let's say that we have in class, you guys got a 75 on one test, you got an 80 on a test, and you got an 85 on a test. And your teacher tells you that, oh, I'm just going to use the average test grades. So in order to take an arithmetic mean, you are going to add all of the data values that all your test scores, and you divide by how many test scores or how many data values you have. So in this case, we're dividing by 3 because there are 3 tests that are taking. We would put in our calculator, and if you're using a calculator, make sure that you put parentheses around the numerator so that's done first before the division, and this will come out to an average test grade of an 80. So that's called the mean of the test grades. It's the average test grade. It also happens to be the median as well, but we'll get there in a moment. Another example is if you were given the values 4, 10, 7, and 15. Again, if we count them, there are 4 in total for data values. So we add them up, divide by how many data values we have, and we get a mean of 9 for the data set. Now, this is fancy schmancy language. This fancy E symbol is a mathematical symbol that means add them up, or the sum, S-U-M, sum symbol. So it's telling you to add your data values and divide by n. Little n is the sample size. Okay, so if we took notes on how to read math, because if you're like, oh my gosh, this is so confusing when you put math formulas in front of me, the reason why it's so confusing is not because you're not good at math, which is what a lot of students say, by the way. It's because it's another language and no one told you that. So it's just like learning Spanish for the first time. Instead, you're learning the language of math. So this fancy E symbol is the sum symbol. That's a U. There we go. Sum. This is referring to add up the data values. And N is the symbol we will use for the sample size. And we'll use that throughout the semester. Little n is the sample size. And if I was to do a problem with a big N, capital N stands for the population size. That is less likely because we typically work with samples more than we'll work with populations. And populations are usually really big and sometimes so big that we don't even know exactly what the size is. We just have a guesstimate. Like the citizens of the United States. We don't have a master list of every citizen, as far as I know. It'd be interesting to know if there is one. As far as I know, the only way to really gauge how many people are in the United States is using registered voter lists, which are all held locally. And the census data that goes out every 10 years that we are required by law to answer, but doesn't mean that everybody actually does. So this is little n sample size is the symbol, big N population size. You're going to want to keep a log. As we introduce more and more symbols, you are going to want to keep a log or a diary, so to speak, of these symbols so that, again, you are essentially decoding the math language. Just like in Spanish, when you learn the word gato, you would write in your notebook that gato means cat, so that you can decode the Spanish into your natural language of whatever it is. For me, it's English. Now, this symbol here is called X bar, and we use X with a bar over it to represent the sample mean. Now, most of the time we are working with sample data, so X bar is going to be very popular in this class, but we still need to know what the symbol is for population mean. So if we did have population data and we were calculating the average GPA for all students at the college, then we would add up every single GPA and divide by how many students we have registered, and that would give us a population mean. And our population mean is this symbol here, which will look totally different when you see it typed. But this is called mu, 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 and that is our symbol for population mean. You're wondering why it's taken me so long to write? Because I'm writing on my iPad and there's actually a lag when I'm sharing my PowerPoint on my computer and when I'm writing on my iPad. There's a lag, so I can't even see what I'm writing, which is why I kind of have to write really slow. Okay, so that's our mean formula and our symbols for sample mean versus population mean. Really important, because as we dive into word problems later on, as the course progresses, we are going to have to decode the word problems. We're going to be taking English and having to put it into mathematical terms. And so we need to make sure that we identify properly what's a sample and what's a population, just like I said way back in chapter 1, because they do come with different formulas. The X bar and the mu are the same formula. Calculating a sample mean and a population mean, there's no difference. You add up all the data values and divide by how many you have. Given some point A and a point X, then X minus A represents how far X deviates from A. This difference is also called deviation. So it sounds confusing, but it's really quite a simple idea. So think of here is Sally. Let's put a dress on Sally, huh? Here's Sally, not Sully, Sally. And let's say that this is John. Okay, now Sally and John are walking together, and let's say that John gets distracted and he walks over here 3 feet away from Sally. So, what is the deviation, or how far did John travel away from Sally? It would be 3 feet. If we were to mark that Sally is in position 0 and John is in position 3, if we're thinking of the coordinate plane and units that he's walked away, so here's a 1 and here's a 2, then what the formula is telling you is that you take 3 minus 0 to find 3 as the deviation. It is literally how far a point is away from another point. So you're finding the distance between those 2 points. An outlier is a data value that is extremely different from other measurements in the data set. Statistically, measures which are not affected by outliers are said to be resistant. Okay, so the mean is definitely affected by outliers. If we have a bunch of tests that are in the 75 in the 70s range, and one person, one smarty pants gets 100, when I calculate the average and I add up all the grades in the 70s plus 100 and divide, I'm going to see the average pulled towards that 100. I'm probably going to see an average of like 85, which doesn't represent the majority of people. If you think about it, if I have 20 values in the 70s and one 100, and now I'm saying the average is 80, 81, 82, depending on how many 70s there were, then I'm really deceiving the person reading that statistic, because it makes it seem like the students actually overall did better than what they did. There was only one person who did in the A range, and everybody else is in the C range. And vice versa. If everybody was in the C range, they all got in the 70s on their exam, and then there was one student who was sick and didn't show up and got a 0. When I calculate the average, it's going to pull the average down and it's going to come out somewhere in the 60s, which is going to be, again, a little misleading because the majority of the class did fairly well. They got a C, but this average, the mean, is showing that it's in the 60 range. So the mean is not resistant. The mean is directly affected by outliers. What is resistant is the median, the middle number, which we're going to talk about shortly. A weighted mean. Now, a weighted mean is when we are working with not only a data set, but a frequency of those data values occurring. So a weighted mean is calculated by this very ugly looking formula, which, thank goodness for us, we do not need to learn it because our guru does weighted means really easily. So let's take a look at this example, and I'm going to do it in our guru. So Megan is a freshman at a college, and she received the following grades for her first semester. In her psych class, she got a B+, and that psych class was 3 credit hours. Statistics, she got an A, of course, and it was a 4 credit course. Anatomy and physiology, got a C-, that is a tough class. Let's say it was a 5 credit course, and English, A-, 3 credit course. Now, when you're doing a weighted mean, which a GPA, calculating somebody's GPA, your own GPA, is a weighted mean. So if you'd like to follow along with your own semester to project your GPA for the semester based on what you think you're going to get as grades this semester, pause the video now, write the classes you're taking this semester, what you believe honestly to yourself, since you're the only one seeing this, what you believe you can achieve as a grade, and the credits of the class. Most classes are 3 credit or 4 credit. 4 credits are usually the ones that, if you're taking anything in the calc track or a lab science, those are normally 4 credit classes. Most other classes are 3 credit, like statistics is 3 credits. So pause the video and do that so you can follow along. After you set this up, again, I'm keep going because you're going to pause and do this. After you set this up, now you have to change your letter grade projection into grade points. So here's a little chart of how we associate a letter grade to a point system. So for the B+, I'm going to write down 3.3. For the A, I'm going to write down 4.0. For the C-, I'm going to assign that the grade points of 1.7, and A- is going to be 3.7. Now, the credit hours is actually the frequency because it just tells you how many times that grade counts towards your GPA. So notice that the anatomy class is worth 5 times the grade. Okay, so I got a C-, so the points of 1.7 are going to count 5 times. So it's much more, has much more of an impact on my GPA, this anatomy class, than the psychology class, because the psychology class is only a 3 credit class. So if you're taking a 1 credit yoga class or whatever at this college, or 1 credit first year experience course, then that grade, if you ace that course, that is not going to contribute as much weighted mean, as much weight as if you were taking a 4 credit science class. That grade is going to count much more. All right, at this time, let me stop PowerPoint and jump over to Rguroo so that I can show you how to do a weighted mean in our software. I just have to find it first. Hold on. It's not showing up at the moment. Is that? Yes, I think this is it. Yes, found it. Okay, so I'm signed into my Rguroo statistical software account. First thing we're going to want to do is we're going to want to go to data, go to data import. You're going to want to create a new data set. You could have done this in Excel and then import the Excel file if you prefer. But once you get the hang of creating a data set in Rguroo, it's not that bad, especially when they're really small like this one. So my first variable is going to be my grade points. Okay, I don't need to put the physical letter grade in here because that's not going to be part of the calculation. We can't do math on qualitative data. We know that, which is why the letter grades needed to be translated into grade points. And I'm also not going to include the subjects because in order to calculate a weighted mean, I just need the data column, which is the grade points, with the frequency column, which happens to be the credit hours. So my grade points, we had 4 classes in our chart. So I'm going to put 4 rows. Again, I add a row by clicking this button here. See if I hover over that button, it does pop up with a little window reminding me what the button does. Double click in a cell in order to type. So the first grade for psychology, we had projected a B plus, or I had projected a B plus. You're going to do whatever your grades are. And that was a grade points of 3.3. My stats class, I projected a perfect 4.0, an A. A C minus in anatomy is a 1.7 grade points, and an A minus in English gives me 3.7. Okay, now I'm going to put in the second variable. I clicked too fast. How I did that was I clicked add a single column. Now I clicked on variable 2 so that I can label this as credit hours. Double click in the cell. The psychology class, make sure you line them up too. They do have to be lined up. The 3.3 grade points goes with psychology, which was a 3 credit class. The stats class, according to this chart, was 4 credits. The A&P was 5, and the English was 3. Once you've completed your little chart, you're going to want to save the data. So name this. I would name it so because it's going to stay in your data sets, weighted mean GPA, so that you know which example this is for, and hit save as. I'm not hitting save as because I've already done this. It's right here. So I already have it in my data set. Now, every time you create a new data table or you've imported something, remember, it still holds true that you should double click on the new one. Of course, my session expired. Hold on. Pause. Signing back in. Okay, let's try that again. Under data, after you've saved your new data set, you always should double click on the data set to make sure it has been made correctly. Again, the things you're looking for is that up here, it really is just labels. And all your data values are in the cells. Okay, now we're ready to calculate the weighted mean. So you can go over here to functions. This is still under the data menu. Go to summary statistic. We're going to select our data set. Well, that's quite strange. It says no data set to select. Let's try this again. Should give me a list. I just practiced this. Okay. We'll try it a different way. Okay. No, that's not going to give me what I want. This worked perfectly when I was trying it out just 5 minutes ago. All right, let me log out and log back in because something's screwy right now. I'm not sure what it is. Problem solving. Things don't always work right. So don't freak out. I sometimes freak out. I'm telling you not to freak out. You just have to sometimes reset your screen by logging out, logging in is very helpful. See, I logged out and logged back in. And now when I hit select a data set, I went to functions, summary statistics, and now I have my entire list of data sets to choose from, which was what I was expecting the last time. I selected my weighted mean GPA. Now, numerical is the data, that's the grade points. The frequency is how often to apply the grade points to the calculation, and that's the credit hours in this case. Some of the data sets you work with are literally going to have data points and a column labeled frequency, which will make it really easy for you to recognize which one's which. Now, this is going to calculate all of this good stuff. What I really only need is the mean, but the median and all of these other data values, standard deviation, those are all things that we're going to cover in the sections we're covering in 4.1 and 4.2. So this is the same place where you would find all of those. I'm going to hit my little eyeball now. I'm going to click on all observations, and here's my weighted mean. It's weighted because I selected a numerical variable and a frequency variable. If I just wanted to calculate a straightforward mean, like those problems where we were looking at test grades, it was just one set of data, the test grades, not two columns, then I would just be selecting test grades for numerical in this basic screen. And there would be nothing selected for frequency. Notice there's a little star, which means required, but there's no star next to frequency because not all mean calculations are weighted. So you only need to fill out the frequency when you're working with a weighted mean, when there's two columns that contribute to your mean. So my projected GPA for the semester that I made up is 3.03. And hopefully if you used your own projected schedule that you can find this data interesting when you look at the weighted mean or what your GPA will be. If this is not acceptable, let's say you calculated yours and you're like, oh my gosh, I really want to be on the dean's list. I need a 3.5 or higher. Then you can go back and adjust your grades to see how can you get a 3.5 and still be realistic with yourself and what you can accomplish in certain classes. All right, let's pop back to the PowerPoint. Wait for it. Here we go. And we're back. So that's how you calculate a weighted mean in Rguroo. The median. Okay, the median, I already talked about that it's resistant. It is not affected by outliers. And it is the middle value of an ordered data set. The median is also given in Rguroo by going to data, over to functions, select summary statistics, and then select the data set that you want the summary statistics of. And the median is actually not labeled median in that report. I should have pointed that out. It's labeled Q2. Quartile 2 and median are the exact same thing. So that's something you're going to want to write down because we haven't learned about quartiles yet. And we won't this week, actually. And so that report is a little deceiving because it doesn't actually label the median in Rguroo. It labels it our Q2, quartile 2. Same thing. Okay, so really important about this definition is that it's the middle number in an ascending order. Okay, so ascending means smallest to largest. So you order the data set first, and then you literally are going to cross off on either side, chunk, 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 until you get to the middle value. Depending on how many data values there are in the set will depend on what that middle value looks like. So here is the procedure. Arrange the data in ascending order, smallest to largest. Determine the number of values in the data set. Find the data value in the middle. If we have an odd number of data values, like 5 data values, then there's going to be exactly a middle number. So notice I cross off, cross off, cross off, cross off. Ooh, maybe I shouldn't have used my hand. How about I try doing this with a pencil this time and not my fingers, because my middle value is my middle finger, and that's not so cute on this. So glad I caught myself on that one. So for example, if we're doing 1, 2, 3, 4, 5, let's keep it simple, then we would be finding the middle value of this ordered set. So I cross off, cross off. And in an odd number of data values, there will be exactly a middle number that we will call the median. Now, when we are working with an even data set, hold on, let me erase. Even data set. So let's take a look at 1, 2, 3, 4, 5, and 6. Then when you're crossing off, you find that there are 2 middle values, but the median is always one value. So what you're going to end up doing when you have an even number of data values is you're going to find the average of the 2 middle values. So you're going to take 3 and add it to 4 and then divide by 2, and we get the median is 3.5. So when you see a 0.5 on a median, you just know that that median was calculated from a data set that had an even number of data values. Okay, so here's another example where you have the following goal tallies from 11 games played by this particular soccer team. First, the data gets ordered, and then we start to cross off. Let me switch my color here. So 1 crosses off with 7, 1 and 6, 2 and 5, 2 and 4, 3 and 3, and here we go. I have my median. It's 3. In this data set, we have test scores for a high school calculus class. Step 1, again, order the data set, cross off on either side until you get to the 2 middle numbers, and calculate an average. In this case, the average of 83 and 85 comes out to be 84. So it is not always the case that there will be a decimal when you have an even number data set, but the decimal will only happen with an even. Here, the data values, there was a middle number in between 83 and 85, so therefore the average came out to a whole number. The mode of a data set is the most frequently occurring value. Now, if your data set, for example, it looks like this. So if we're working with a data set 1, 2, 3, 4, 5, there's no mode. So if there is no repeating values in the set, then there's no mode. That's okay. Now, if there was another 4 in this set, then we would say that the mode is 4, because 4 has the highest frequency. It has the highest repeating. It's the most repeated data value. It's possible that you might have 2 of the same frequency. So let's say that there was another 3 in this data set. So we would call this data set then bimodal, because bi, as you are bipeds with 2 legs, bi means 2. So bimodal means 2 modes, and you would say that the mode is 3 and 4. Okay, in this data set, if we are looking, I find it easiest to identify a mode if I order my data set first from smallest to largest. And then I make less mistakes because all the same numbers are clumped together. But I can see that 0 is repeated 3 times, 1 is only repeated twice, 3 is only repeated twice. So 0 is the mode because it's the only one that's repeated at the highest frequency of 3 times. Okay, however, as noted previously, the mode does possess one very favorable property. It is the only measure of location between mean, median, and mode that can be applied to nominal data, qualitative data. You cannot calculate an average for qualitative data. It doesn't even make sense. How do you add categories and divide? And you can't calculate a median because remember, nominal data doesn't have an order to it. So there is nothing to order to find the middle value. But mode, however, if we have data that is qualitative, it is possible the qualitative data can repeat. So for example, if we take a look at this chart, we say we did a survey and asked people to identify as Democrat, Republican, Independent, or other / don't know. And then we have the frequency or the count of the results. 46 people selected they identify as Democrat, 34 people as Republican, 39 people as Independent, and 5 other don't know. We would say the mode is Democrat because Democrat was the highest frequency. So it is good to know that mode is typically used and is very useful for qualitative data as it's the only measure of location that works for nominal level data. So this concludes 4.1. See you next time.